Okay, let's start a new section, subsections. So the 1.4 subsections are polynomials, operations on polynomials, and special products. Okay, we start with monomials. Okay, one monomial is what? Okay, monomial is one term. It says just one term, one term. So it's a real number or a product of real number and one or more variables with non-negative integer exponents. So you might have different variables in it, but they're multiplied. So they're all multiplied and there's no addition, subtraction in it. It's all multiplication, and the exponents here are all positive. So this is a monomial. So you can take the monomial as one term polynomial. So there is only one term in a polynomial. So this is called monomial. And the real number in front is called coefficient of the monomial. So the coefficient of this one is obviously -1/2. And when you look at here, we have this negative, but this negative means -1. So you can view this one as -1 times u squared times v cubed. So this is the coefficient of it. Okay, what's the coefficient? If you don't see anything, in front, so it means like 1 times. So 1 is the coefficient, and this is a monomial with a, b, c in it. And 15 is a constant monomial. So you can view numbers as constant monomials, and its coefficient is 15. So the simplest monomial, we take it as 1. So 15 times 1, so 15 becomes the coefficient. Degree of a monomial is the sum of exponents of its variables. So exponent means us, okay? All non-zero constants have a degree 0. Okay, have a degree of 0. So when you see a constant number, it's degree 0. And the number 0 has no defined degree. So look at those. So look at the powers here, but the powers of variables only. Okay, 2, 1, 1. So it makes 4. 2 plus 1 plus 1. Here it's 5 because 2, 3, 2 plus 3. Here it's 7 because 1, 1. Okay, it's 1 plus 1 plus 5. So 7. So when you look at the degree of a number, it's by default it's 0. Because if you put a variable next to it, so it will be, you will not see the variable, you will see just 1. It's 15 multiplied with 1. So 1 can be taken as the 0th power of any variable. Now the polynomials. Polynomial is a monomial or sum of monomials. So each monomial in that sum is a term of the polynomial. And a polynomial with 2 terms is called a binomial. A polynomial with 3 terms is called a trinomial. So then you have only one term here in the monomial, mono, 1, bi, 2, and 3, 3, okay, terms. Okay, when you say monomial, okay, so monomial, so it means like one term. Binomials, 2 terms. Trinomials, 3 terms. So look at here, a monomial. These are all monomials. But binomial, we have 2 terms, added or subtracted. Added or subtracted. These are all binomials. When you look at the trinomial, you have 3 terms, added or subtracted. You can also make, I can write this one as, subtraction and addition. So the important thing is we have to have subtraction or addition here. Degree of polynomials. The degree of a polynomial is the degree of its term with the highest degree. Okay, the degree of The polynomial is degree of its term with the highest degree. A non-zero real number is a polynomial with degree 0. We will accept this way. And the number 0 is a polynomial with no defined degree, is called a zero polynomial. Okay, let's look at here. So let's look, it says for the polynomial, identify the coefficient and the degree of each term, then find the degree of the polynomial. So let's go with the degree of the polynomial. First degree of the polynomial was the degree of its term with the highest degree. Okay, now what is the degree of this? It's 1, 3, 4. So you add them, you got 8. 3, 1, 4. 1, 1, 2. 1, 1. So because if you don't see any power here, it means 1. So x squared, here we have 2, and this 9 is a constant thing, so it's 0 degree. Sorry, it's any real number is 0 degree. Okay, then what's the biggest degree? It's 8. So the degree of the polynomial will be 8. Okay, let's look at all the terms. Okay, when you look at the terms, the coefficients. Okay, if you don't see any coefficient, it means 1. I mean, any number before the term, it means it's 1. So negative 15 coefficients are these. And then degrees, when it comes to degrees, you know the degrees are those. And the polynomial has a degree of 8. Okay, it's a degree 8 polynomial. So it's 8 degree polynomial. Like terms, the like and similar terms are of a polynomial are either constants or terms having the same variables with the same exponents. And to combine like terms in a polynomial, we add or subtract their coefficients. So terms with the same variables with the same exponents. Like it means, okay, these are like terms. We can add them, but these are not like terms, because the powers here not same. You see? So these are not similar terms. Okay, we will see some examples of it. For example, these are same. Look at, okay, match the powers also. 2, 2, 1, 1. So the coefficients, when we add them, we will add their coefficients. So it will be 7x squared y. Now look at them. Are they like terms? Yes. 2, negative 5. So 2 minus 5. So it will be negative 3. And okay, here is the warning. Only like terms can be added, subtracted in a polynomial. So sometimes some people do it this way, like, okay, I add them, so I get 2x, y, or y squared. This is wrong. They cannot be added. Okay, yes, here, for example, in this polynomial, we cannot add them. Okay, we cannot combine them because they are not like terms. You know, look at the powers, and they're not same. Okay, let's look at these two examples and let's try to combine them. Simplify the following. Simplify means make it simple, you know, add, if possible, the like terms and try to get a short expression for it. So here, are there any like terms? Are they? No, these are not. So look at here, this one and this one. See, like terms. And okay, let's see the solution. So we have like terms here. Identify the like terms. First we do them, and then we combine them. We put them together. We put them together here, so they make 4 plus 3 x squared y, and the rest remains same. So we add them, and that's it. We cannot do more than this because we don't have like terms anymore. So let's look at here, and here these are the like terms, and like terms. So then we will combine them. So we will put them together and try to do the operation between them. So 2 minus 1 minus 3 times x cubed y minus y minus xy. So you do this calculation here, you get this one. Now let's look at the polynomial in one variable. And the first thing we will see is the standard form of a polynomial. A non-zero polynomial in one variable x can be written in standard form. Okay, so pay attention to this phrase here, standard form. When we say standard form, you will see the the power of the monomials, the degree of the monomials will be in order. You know that tartib is important here. So if you have like x cubed, you have to have x squared, x to the first. So some of them might not appear, but this decreasing order has to be there, okay? It has to be in decreasing order. So n minus 1, n minus 2. So this is important. And here, these are the representatives for the coefficients. So we put this indices here. 1, okay, it corresponds to the coefficient of x to the first. And this one is the representative for the coefficient of x to the n minus 1. Now, n here cannot be a negative integer, so it's non-negative. Non-negative means 0 or positive. 0 or positive. That's one thing. And the degree of this polynomial is, of course, the highest degree monomial. I mean, the highest degree. So of the monomials. So it's the degree is polynomial of the polynomials n. And the leading coefficient, okay, here this phrase is also important. The leading coefficient is the coefficient of the term with the highest power, so a sub n, and the constant term is if it exists. Sometimes, like if it's not, so we say it's 0, but you can see a non-zero number here without x, so we call it constant term. So constant term of a polynomial. And here, okay, I want to emphasize the standard form here, the phrase standard form, because these two polynomials, indeed, they are same. They represent the same polynomial, but only this one is in standard form because here, look at the degrees of the x terms. So it goes increasing. So no, decreasing. So 2, 1, and it's in order, in order. So there's tartib. Okay, so we are looking for tartib for each polynomial. So if there's this order, a decreasing order of the powers, then we say it's standard form. And one other thing here is, okay, let's look at this one here. The coefficients of missing terms are automatically 0. So look at here. So indeed, if it is like the third degree polynomial, we expect x squared somewhere and x and also a constant number here. So indeed, the x squared here, we don't see x squared because its coefficient is automatically 0. So if it is 0, so you don't see this one here. And also you don't see this one if the constant is 0. So if you see only this, the missing parts are 0. Okay, let's look at this example. It says, write each of the following polynomials in standard form. So this is the key word here, key phrase, and indicate the degree, the leading coefficient, and the constant term, and the coefficients of x to the fourth for each of them. So it's asking lots of things here: degree, leading coefficient, constant term, and the coefficient of x to the fourth. Now let's look at here. Before telling, okay, so first it says write it in standard form. So okay, first check if it is in standard form. Look at the powers here: 7, 1, and then 2, and then there's 1 here. So there, okay, it goes like 7, 1, 2, 1. It's not in decreasing order. So it's not in standard form. And in the standard form also, we will not have 1, 1. So we have to combine them, okay? We have to combine them. And when we look at this one, it's also, it doesn't start with the highest degree because the highest degree is here. So it has to start with this. So we have to change the places of monomials to write them in standard form. Okay, now let's look at here. The standard form will be 7 x to the 7, negative 7 x to the 7, then plus x squared plus 11x minus 1. So here, what we do first is if there are some similar or like terms, that we add them. So when you add them, you got negative 7 to negative x to the 7, and then plus 11x plus x squared minus 1. But as you see, this x has degree 1, so we want to switch these two. Okay, when switching them, okay, you will take their signs. Okay, you will include their signs. So then now you can switch. And when you switch, you got negative 7th power of x, and then x squared, and then plus 11x to the first, then minus 1. You don't have to write 1 here because if you see nothing is written, it's automatically 1. And the degree is automatically 7. And the leading coefficient of x to the negative, okay, the leading coefficient is the coefficient of x to the 7th. That will be negative 1. Constant term, negative 1. And the coefficient of x to the 4th. Okay, look at here, the x to the 7th. And then we jump to x to the 4, x squared. So automatically the missing ones here, like 6, like 5th, and the 4th, and cubed, so automatically their coefficients are 0. Okay, let's look at the other question. In this question, there is no similar terms here, no like terms, so we don't add or subtract them, we don't combine them, and the only thing we need is to change the places of these. Okay, these, because it goes like 1, 3, 4, 5 the degree, so we have to reverse it. So plus x to the 5th, then negative 5x to the 4th, then with, I'm taking with their signs, okay, negative x cubed, and then if you don't see a sign here, it's plus, so we say it's plus 2x. So this turns out to be our polynomial in standard form. So you can erase this plus here. Okay, the first one, if it is plus, you can erase it. If it is minus or negative, you have to keep it there. Okay, then after this, it's easy. The rest is easy. Degree, the biggest degree is 5, for sure. And the leading coefficient here is 1. And the constant term is, okay, plus 0. We don't see a constant term, so it's automatically 0. The coefficient of x to the 4th is negative 5. Okay, let's look at the operations on polynomials. Addition, subtraction, multiplication of polynomials can be done similar to real numbers. So it means all properties of these three operations, the properties خاصية, okay, commutativity, associativity, okay, remember this. What does this mean? A times B is equal to B times A, or A plus B equal to B plus A. And the associativity for multiplication and for addition. And distributivity, we can also use distributivity, so it means like and yeah, you know, this one here, right, left, distributive properties. Okay, I think you will remember them. Okay, these are all valid. And only like terms here, the important thing is only like terms can be added or subtracted, and all like terms should be combined in every operation. And in multiplication, polynomials must be written in parentheses. This is very important here. Okay, let's look at an example of adding and subtracting polynomials. Okay, two polynomials are given here, and we add them here, and we do subtraction here. In addition, you can remove the parentheses here because this addition doesn't change the things. So we just look for these similar terms. So these are similar terms, so we combine them. We combine these two. We combine the numbers. And these like terms, we put them together. We can change their places by taking their signs together. Okay, what else? Let's see. So here are the like terms, and we change their places. This becomes, okay, it came up to here, and negative 2a came to here. Anyway, we do the same for the others, and then we calculate. This makes negative 3ab, this makes 8a squared b, and this makes 6. Let's come to the subtraction. In subtraction, we have negative term here, so you will distribute this negative to all of them. So then you will have negative, negative, positive, and then you have negative. So negative, positive, it will be negative, 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 it will be positive. So then now we can combine the like terms. Combine them. We'll get these two. Minus 2xy. And we don't have anything to combine, and that's the answer. Let's look at this example. Compute the following and write the answer in standard form. Okay, so standard form, this is an important word here, the phrase. Okay, let's do this addition and subtraction. And also it says subtract from, okay? Subtract this polynomial from that polynomial and write the difference in standard form again. So standard form again. Okay, I think this is clear. So you will do the job, and then you will write, if you have like, you will write them in like x cube, x squared, x to the first, and if you have them, okay, in this order. Now let's look at this one. Subtract means find the difference, but find the difference, so it means like subtract this from this one. So okay, negative, so we distribute negative here. So we remove the parentheses then. So what do we get? We get this one. So as you see here, plus, and the negative plus, negative times, okay, plus 1, so it will be, okay, positive 1, it's negative 1. Now we look at the like terms. We combine the like terms. Look here, you can bring them together. And bring these together, like this one, okay, and this one. And also we do the same thing for the x. Okay, this is extra. Okay, one of them is extra. And then we have x here, and then plus one. We can combine them, at the very back, and they become. When you combine them, you will have this. So how to add these two? And okay, this is extra. These two, because they are like terms, and this they make 0, of course. Okay, here in this case, so you look at here, this is 1. So this 1 and 1 over 3, and this is like common factor here. So you take x cubed out, so you have this one. Take x squared out, and we have this terms here. This becomes 0. Okay, when you do this one here, 1 plus 1 over 3, so you get 1 over 1, so you get 3. And 3 over 3 plus 1 over 3, so it makes 4 over 3. And here, this one, 1 minus 1 over 2, so it's 1 over 1, so 2 over 2 minus 1 over 2, so you got 1 over 2. Okay, I raised those. Then that's the answer. Okay, this is the answer. This is the polynomial in standard form. Yeah, this is a polynomial in standard form, as you see, 3, 2, 1. So the degrees are in order, so it's a standard polynomial. Okay, let's see an example of multiplying the polynomials. Okay, here it says expand and simplify. So expand means, do this, like get rid of the parentheses, and simplify means like try to combine the similar terms if possible. So first we can use the distributive property of multiplication. So we 3x times this whole thing, and 2y times the whole thing. Now I can do the distribution again separately, okay, like one by one. So as you see, it will be this one, and this one. For these, okay, you multiply them, you got this one, multiply them, you got this one, you multiply them, you got this one. Now after doing this multiplication, and here when you multiply, what happens? 6x times like x squared here, so you got 1. So remember the power rule, the sum of the powers. So when this is multiplication, you add them. It's multiplication, you add them. And same thing for all of them. And then if there is similar terms, we add them, like here, look at here. Similar terms, you add them, and then when you combine them, like, okay, combine these, and we will end up with this. The rest remains same. So we don't talk about the standard form here, guys, because we have x and y. So the standard form is with x only, okay? If the polynomial is written in x. Okay, let's look at the try and check. Okay, stop the video here and try to do it by yourself, and I will try to do it myself here. Okay, so I will do a quick multiplication here. So you can do it this way, like here, or if you are good at this, you can directly try to do it like that. So some people says it's a banana split or something like this, but anyway. Now let's deal with this, and it will be, and it's 12 rs squared, and this is plus 6s cubed. So then there will be this and this. These are negative 20 rs squared, and there's nothing with s cubed. And these two, they make 10 rs squared, no, r squared s. And at the beginning we have 8 r cubed. Okay, 8 r cubed plus 10 r squared s, negative r s squared, and plus 6 s cubed. Okay, I can erase this. So the answer is now at 8 r cubed plus 10 r squared s, and negative 20 r s squared plus 6 s cubed. Now, what was some special products of special products of binomial polynomials, or binomials, let's say. Okay, first, two expressions of the form a minus b and a plus b are called conjugates. So this is important here. So if someone asks you, like, what is the conjugate of a minus b, you say a plus b. What's the conjugate of a plus b? It's a minus b. They are conjugate of each other. And the products related to these polynomials are called special products. So we will have some formulas for their products. Now, the product of conjugates, if this is the case, then it's automatically a squared minus b squared. And the square of a binomial, okay, sum, okay, a square of a sum, okay, let's say sum of a binomial, it's a plus b squared is equal to a squared plus 2ab plus b squared. And the square of a difference, it will be a squared negative minus 2ab plus b squared. Okay, then these rules are, these formulas are coming straight from straightforward multiplication. Let's see one of them, like this one, for example. Where does it come from? We distribute, basically, and let's see what happens. Now, when you distribute, you got like a times a, it will be a times b, so it's plus ab, and negative b times a, so it will be negative ba, and then negative b times plus b, so it will be negative b squared. So as you see, they're same because we have this ab is equal to ba. What is that? This commutative property of multiplication, right? So they cancel out, and we have a squared minus b squared. Okay, now if you do these, the others, you will get the formulas. Okay, indeed, you need to, you don't need to memorize them. You can directly derive them by yourself. So you can do, if you do this job, and you will end up with the results here. So these, for example, for this one, a plus b squared, write it this way, and do it, you know. Okay, multiply and simplify the following expressions using special products. Here, you can directly multiply, okay? One thing is you can directly multiply, okay? Like 2x. One way is to multiply directly. So it means 2x minus 5 and 2x plus 5. So directly do this multiplication. But it says use special products. So it says use special products, so I will try to use them. So when you look at here, so you have to understand what type of special product can you use? Because here, if you say this is A, and if this is B, so we have like A plus B. So like if A is 2x and B is 5, then we have this A minus B times A plus B. And here A plus B squared. This is A minus B squared. So then again, if this is A, this is B, this is A plus B, so you end up with this product. And we know the formula for this product. We have this. So then we substitute 2x and 5 in this product. In this expression. So 2x and 5, okay. It's better you put them in parentheses, and then you get this one. Now for the other one, so you can say this is A and this is B, and A plus B squared is equal to this one, and then substitute means like put it back, put something for it. So substitute 2x for A, for B, okay. It's better you put them in parentheses. It's not given in parentheses, but it's better you put them in parentheses. And you do the multiplication and the simplification if possible. Okay, in the last one, it's the same idea. And we use this, and then we substitute 2x and 5. Again, it's better to put these in parentheses, and then we end up with this one. Okay, okay, stop here and try to do it by yourself, and I will just give you the answers. I will not solve the problem here, so you can check yourself. If you couldn't figure it out, then you ask your teacher. This one has to be 9c to the 4th, and 24. C squared d cubed, and then plus 16 d to the 6th. Okay, use A, B squared, you know what to do. This is A, B, so A minus B times A plus B, so it will be 9c to the 4th, 16d to the 6th. And look at your A, B squared, so you can write here 9c to the 4th plus 24c squared d cubed, and plus 16d to the 6th. Okay, let's look at this example. Derive a simplified formula for A plus B cubed. So basically it says, find what it is. Okay, derive means find out a simplified formula, find or develop. So how can we do it? And the other question is write this one using part A. So we will use this formula. We will get a formula for this, and then we will use the formula here. Okay, for part A, we can do this. The first thing you have to see is this cube means like A plus B, its first power times A plus B squared. Now, do you know what it is? Yes, you know it. This one is A squared plus 2AB plus B squared. Then we can use distribution law. Then after combining the similar terms, we get, okay, 2 here and 2A squared B, and this is okay, these two combined and these two combined, right? Okay, so it gives you these terms. And then we got the formula. The formula is for the a plus b cubed, the formula is a cubed plus 3a squared b plus 3a b squared b cubed. And if you want to use this one, okay, if you want to do it, so it's a is 2 and b is x, so you put here 2 cubed plus 3, 2 squared, x, and then 3 times 2, x squared, like x squared, and then b x cubed, you know. You can do, yeah, you can write it this way, then you will get the solution. Now, let's look at this try and check problem. Okay, stop the video here and try to do it by yourself. Now, let's try to find a formula for a minus b cubed and write that polynomial for 2 minus 3x cubed in standard form. Okay, let's do it. Okay, a minus b cubed. So a minus b cubed. Okay, square. That will be a minus b, a squared minus 2ab plus b squared. Then, you know, do this, and like you can also do this one here, you know, you multiply, and at the end you will get a squared minus 3a squared b plus 3ab squared, and then minus b cubed. But you do the job here, so but the answer will be this. And if you want to get, I don't remember the, okay, I think it was 2x minus 3. So if it is, okay, if you're taking the cube, so a will be this one, and then b will be this one. A is equal to 2x, and b is equal to 3. Okay, let's do it. Let's put 2x cubed minus 3, 2x squared, b is 3, and then plus 3 times 2x, b squared, 3 squared, minus 3 cubed. And then this will make, okay, it's like 2x cubed means like 2 cubed times x cubed. So this is multiplication, so you can distribute, you know, the powers. So this will be 8x cubed. And in the same way, you can do this calculation, and at the end you will get 36x squared. And if you do this job here, you will get 160, no, it's 54, sorry, 54x, and then this will be minus 27. It has to be negative 27. Okay, that's it. Thanks for watching.